Hello, my dear children. Today we are going to discuss the concepts in exercise 1.3. Before going to start the sums in exercise 1.3, we have to learn these concepts. We have to learn these points well. So, the first concept, the first point in this exercise, subset. What is meant by a subset? What is the definition of a subset? Let us discuss it now. Okay, my dear children. A set A is said to be a subset of B if every element of A is also an element of B. This is the definition of a subset. In other words, A is a subset. This symbol stands for subset. A is a subset if whenever A belongs to A. You know this symbol, how to read it. A belongs to A. A is an element of set A. Then A belongs to B. Okay, my children. It is often convenient to use the symbol implies, which means implies. This symbol stands for implies. Using this symbol, we can write the definition of subset as follows. So, we can write the definition of a subset as this statement. A is a subset B if A belongs to A implies A belongs to B. If this condition is satisfied by the set A, then A is said to be subset of set B. Okay, my dear children, we take some examples also to understand this concept. Okay, my dear children, right. We read the above statement as A is a subset of B if A is an element of A implies that A is also an element of B. If A is not a subset of B, we write it as A is not a subset B. This symbol stands for not subset. Remember these points, my dear children. We may note that for A to be a subset of B, all that is needed is that every element of A is in B. Okay, my dear children, it is possible that every element of B may or may not be in set A, but every element in the set A must be in the set B. Then only A is said to be a subset of B, but every element in the set B may or may not be in the set A. Understood, my dear children? Right. If it so happens that every element of B is also in set A, then we shall also have B is a subset A, because every element in the set B is also an element in the set A. Then we can say that B is a subset of A. In this case, A and B are the same sets, means they are equal, so that we have A is a subset B and B is a subset A. By implies A is equal to B, where this symbol is a stands for two-way implications. Remember these symbols, my dear children. This symbol stands for subset. This symbol stands for by implication. Okay, two-way implications. Not only here, in higher classes, in future they are very very important symbols, and usually read as if and only if. This symbol is also read as by implication or if and only if. It is also read as if and only if. Briefly written as IFF. IFF stands for if and only if. Remember these points, my dear children. Okay, my dear children? Right. It follows from the above definition that every set A is a subset of itself. As in the case of number system, every number is a factor of the number itself. Here also every set is a subset of itself. That is, A is a subset A. Remember this point. Whenever you are getting the word subset in the question, immediately you have to remember this point. Every set is a subset of itself. Now, since empty set 5, do you remember this symbol? Empty, this symbol stands for empty set, null set, void set. In the first exercise, we have learned it has no elements. We agree to say that 5 is a subset of every set. As in the case of number system, 1 is a factor of every number. Similarly, here also you have to remember that empty set 5 is also a subset of every set. Remember, for any set, the subset is the set itself, and 5 is also a subset of the every set. Okay, my dear children? Right. Now, let us consider some examples to understand the concept of subset. Okay, my dear children? We now consider some examples. See the first example. The set Q of rational numbers is a subset of the set R of real numbers, and we write Q is a subset of R. You know that in the set of real numbers, all rational numbers and all irrational numbers include. They are made up of real numbers. All rational numbers and all irrational numbers together made up of real numbers. That is why the set of rational numbers is a subset of real numbers. Understood this example, my dear children? Right. Now come to the second example. If A is the set of all divisors of 56 and B is the set of all prime divisors of 56, then we can say that B is a subset of A, and we write B is a subset A. Okay, my dear children, remember this is read as B is a subset A, because here let us write the given set A in the roster form. What is the set A? The set of all divisors of 56. See, here I have written the factors of 56. 1 into 56, 2 into 28, 4 into 14, 7 into 18. Then what are the divisors of 56? 1, 2, 4, 7, 8, 14, 28, 56. I wrote all the divisors of 56 as set A. Now come to set B. What is the set B? B is the set of all prime divisors of 56. What are the prime divisors? Means prime numbers. What are prime numbers in these numbers? 2 and 7 only. So here B is equal to set 2 and 7. Now if you observe that every element in the set B, 2 is in the set B, it is also in the set A, and 7 is in the set B, it is also in the set A. So every element in the set B is also an element in the set A. That is why we can say that B is a subset of A. Understood this example, my dear children? Right. Now let us take another example. Let A is equal to set 1, 3, 5. These are the elements in the set A. Okay, my dear children? And B is equal to set of all x such that x is an odd natural number less than 6. This is a set B. Then A is said to be subset of B, and B is also a subset of A, and hence we can say that A is equal to B, because B is equal to, if you write the given set B in the roster form, what are the elements in the set B? 1, 3, 5. Isn't it or not, my dear children? In the first exercise we have written the sets in the roster form when it is given in the set builder form. So if you compare these two sets, every element in the set A is also in set B. So we can say that A is a subset B, and every element in the set B is also in the set A. So we can say that B is a subset of A. Here A is a subset B and B is also a subset A. In that case we can say that they are equal sets. They represent the same sets. Understood, my dear children? Right. Now let us take another example to understand these concepts very clearly. I am taking another example. Let A is equal to set A comma E comma I comma O comma U. These are the elements in set A, which is nothing but these are vowels in English alphabet. Do you remember this one, my dear children? Yes. And B is equal to set A comma B comma C comma D. These are the elements in the set B. These are the first four letters in English alphabet. Okay, my dear children. Then A is not a subset of B. Also, B is not a subset of A, because so here A is an element in the set A. Here A is an element in set B. E is an element in the set A, but E is not an element in the set B. So even a single element is missing, then the set is not said to be a subset of the second set. Every element in the set should be an element in the second set. Then we can say that the first set is a subset of the second set. Similarly, every element in the set B is not an element in the set A. That is why here the set B is also not a subset of set A. Understood, my dear children? Right. Now next definition, proper subset. Previously we have discussed a subset. Now come to the definition of proper subset. Let A and B be two sets. If A is a subset B and A is not equal to B, then A is called a proper subset of B and B is called superset of A. This is a definition of a proper subset. For example, to understand this concept, let us take an example. See here, A is equal to set 1 comma 2 comma 3 is a proper subset of set B is equal to set 1, 2, 3, 4, 5. If you observe these two sets, every element in the set A is also in the set B, but A is not equal to B. So here A is said to be a proper subset of set B, and here B is called superset of A. Understood this concept, my dear children? Right. Now come to the next point, third point. Intervals as subsets of R. What does the letter R stands for? Set of real numbers. Okay, here we denote the set of real numbers in the form of intervals. Let A and B belongs to R, means A and B are two real numbers and A is less than B. A is a small number and B is a bigger number. Now different in types of intervals. These are all subsets of the set of real numbers. Okay, my dear children. So first one, here it is called set builder form. Here interval notation. First one, set of all x such that x is a real number and a less than x less than b. If you observe here, these are endpoints. These endpoints does not include in that interval. This is denoted by open interval a comma b. Here small brackets. We use here small brackets to denote open interval. This is called open interval a comma b. Understood this point, my dear children? Right. Now come to the second point. Set of all x such that x is a real number and a is less than or equal to b. Now come to the second interval. Set of all x such that x is a real number and a is less than or equal to x less than or equal to b. If you observe here, the end points A and B also the elements in this interval. We denote this interval like this, closed interval A comma B. On both sides we use square brackets, whereas here we use small brackets to denote open interval, whereas here we use square brackets to denote closed interval. This interval is read as closed interval A comma B. Understood this point, my dear children? Right. Now come to the third interval. Set of all x such that x is a real number and a is less than or equal to x less than b. A is less than or equal to x less than b. In this set, in this interval, this end point is an element, whereas b is not included. B should not be an element in that interval. B is not an element. This is a set builder form of this interval. This is a notation, interval notation. Left closed A and right open B. This is called left closed right open interval A comma B. This interval denotes a subset of real numbers in which A is an element but B is not an element. But in between A and B all the real numbers including A. Understood this point, my dear children? Right. Now come to the next interval. Set of all x such that x is a real number and a less than x less than or equal to b. If you observe this interval, in these two endpoints, a is not included, means a is not an element in this interval, but b is an element less than or equal to x is less than or equal to b, means b is an element in the set in the interval, but a is not an element in the interval. We denote this set in the interval form like this: left open A, right closed B. This is called left open right closed interval A comma B. This is also a subset of real numbers. Now come to the next interval. Set of all x such that x is a real number and x is less than or equal to a, means we have to take all the real numbers less than or equal to a. We denote this interval in this form: open interval here minus infinity comma a. All the left side numbers on the number line, imagine number line, all the numbers left side to the number a, including the element a. In this interval, a is also an element. Understood this point, my dear children? Square bracket means that element is also an element in the interval. Right means open interval means that element is not element in that interval. Next, set of all x such that x is a real number and x is less than a. X is less than a. Here minus infinity comma a. Minus infinity comma a. So here a is not included. All the numbers less than a, minus infinity on the number line, left side numbers, but a is not an element in that set. In that interval, a is not included. Understood this interval, my dear children? Right. Now come to the next interval. Set of all x such that x is a real number and x is greater than b. So all the real numbers which are right side on the number line, on the right side of the number b. So we denote it in the form of interval like this: open interval b comma infinity. Understood this interval, my dear children? Right. Now come to the eighth type of interval. Set of all x such that x is a real number and x is greater than or equal to b. Here greater than or equal to b means b is also an element in the set. In that interval, b is also included. So we denote it that interval in this form, closed interval b comma infinity. And the last one, the set of all real numbers. We denote this set of all real numbers as open interval minus infinity comma infinity. Remember all these 9 types of intervals, my dear children, as subsets of real numbers. Okay, my dear children, right. On the real number line, various types of intervals described above as subsets of real numbers are shown in the following table. This is called geometrical representation of intervals. Okay, my dear children, we are representing the intervals geometrically. See here, first interval, open interval a comma b. You know how to read this interval, open interval a comma b. In this interval, all the real numbers between a and b, excluding these two endpoints. See on the number line, a small number left side we wrote here, b is a bigger number. Here see here, small hole is there at a and a sub small hole is at b. It means the two numbers does not include in this interval, but all the real numbers between a and b, it is shaded by these slant lines. Understood this, my dear children? Right. Now come to the second interval, closed interval a comma b. You know, in this interval, the end points a and b are also the elements in that interval. That is why on the number line, see here, a and b, here square brackets, whatever the brackets are used here, we are using the same square brackets. Between the two numbers, all the real numbers will be the elements, including the endpoints a and b, because closed interval means the endpoints also elements in the interval. Now third interval, left closed, right open a comma b. Left closed, right open interval a comma b. In this interval, if you observe, a is an element, a also included in that interval, but b is not an element. So we are representing this interval on the number line like this. See here a, here b. At b, a small hole, I kept a small hole, means that number is not included in that interval. That is not an element. B is not an element, but a is an element in that interval. Understood, my dear children? Right. And the real numbers between a and b. Okay, my dear children, understood this point? Understood these representations of geometrical representations of intervals, my dear children? Right. Now come to the next interval, left open, right closed interval a comma b. To denote this interval geometrically on the number line, see here on the number line, at a I used here open bracket, as here we used open bracket. At b we are using closed bracket, square bracket, square bracket. In between these two numbers, all the real numbers I shaded to denote all the real numbers between a and b are elements in that set. Here b is also an element. Square bracket means that element also included in that interval. Understood, my dear children? Right. Now come to the next interval, minus infinity, open interval, minus infinity comma a. To denote this interval geometrically on the number line, see here on the number line a comma b. At a, small hole is there. See there, see the interval, see that geometrical representation carefully, my dear children. Here open bracket, here less than a, all the elements left side of this number a, I shaded this part, all the real numbers left side to a are the elements in that interval. Understood, my dear children? Right. Now come to the next interval, open interval minus infinity comma closed interval a. So here a is also an element in that interval, but all the left side numbers to a. Here I shaded to denote all the elements belongs to that interval. This is shaded region denotes all the elements which are lying in that interval. Understood, my dear children? Here A is also an element in that interval. Okay, my dear children? Right. Now come to next interval. Open interval B comma infinity. To represent this interval geometrically on the number line, see here on the number line A comma B. Here all the numbers greater than B, but B is not included. Here a small hole is there at point B. So it means that B is not included in that interval. It is not an element in that interval. Okay, my dear children? Right. And the last one, close interval B comma infinity, means to represent this interval geometrically on the number line. See here on the number line A comma B, all the numbers greater than B, including the number B. B is also an element in that interval. Understood these intervals and their geometrical representation, my dear children? Right.